Hi, I'm Sophie Dorland, 3969368.
I am Harriet Mathew, and it's 3933558.
In this video, we demonstrate Q4 proactive threat hunting using a Suricata event log. Our goal is to identify whether the client network contains potential database-related attacks. We first filtered the full event log to extract only database-related alerts. Based on these alerts, our hypothesis is that the system is undergoing a coordinated database-related attack campaign targeting MongoDB and Redis services. Next, we count the database alert types. The output shows 4 main database-related alerts. The high volume of Redis and MongoDB alerts shows that these are not isolated events. This gives initial support to the hypothesis that database services were being targeted. Then, we identified attackers and targets. Key source IPs are 2030.113.42 and 185.22.1.5. The key targets are 10.0.5.30 and 10.0.5.20. This shows that suspicious activity was concentrated around specific attackers and specific internal database-related systems. And then we validate the database ports. We found out that 10.0.5.30 was targeted on port 6379, which is associated with Redis, and 10.0.5.20 was targeted on port 27017, which is associated with MongoDB. This validates that activity was specifically targeting database services.
We first investigated the MongoDB port scanning alerts. Our analysis identified a single source IP address, that is 185.22.1.5, generated 5,000 alerts targeting the internal host 10.0.5.20. The timeline analysis shows that these alerts started on the 12th of May at 4:20 and continued until the 13th of May at 12:39 a.m., indicating sustained activity over several hours. We also analyzed the alert frequency. This showed that approximately 10 scan alerts were being generated every minute. So the consistent alert frequency combined with the long attack duration strongly suggests automated reconnaissance activity. Next, we investigated the Redis config command abuse alerts. The analysis identified the external IP address 203.0.113.42, generated 30,000 alerts targeting the host 10.0.5.30. The activity occurred from the 13th of May at 1720 until the 15th of May at 1919. The alert frequency analysis again showed that there were approximately 10 alerts per minute, and this is consistent alert generation, which basically means that it's automated exploitation related behavior. After identifying the reconnaissance activity, we investigated MongoDB credential guessing alerts. The analysis showed that the same IP address generated 20,000 alerts targeting the same internal host. This activity started on the 17th of May at 4:40 and continued until the 18th of May at 13:59. We again analyzed the alert frequency and found exactly approximately 10 alerts were generated every minute. An important finding here is that the same attacker had targeted the same target host, and it appeared in both the MongoDB scanning and the credential guessing. Finally, we investigated the suspicious large database transfer alerts. The alerts identified the same IP address communicating with the same host, which had been previously targeted during the MongoDB scanning and credential guessing activities. The activity occurred from the 18th of May at 10:20 until the 19th of May at 6:39 a.m. Frequency analysis again showed that approximately 10 alerts were generated every minute. This is again an important finding because the same attacker IP and target host appears across 3 separate database-related alert attacks.
Put all findings together, several important patterns emerged. First, the same attacker IP address appeared in MongoDB scanning, MongoDB credential guessing, and suspicious database transfer activity. Second, the same internal host 10.0.5.20 was repeatedly targeted across these different attack categories. Third, the attack specifically targeted MongoDB port and Redis port, confirming that database services were the primary focus. Finally, timeline analysis showed that the activities occurred across multiple days and involved repeated alerts generated at regular intervals. Although the timeline does not confirm a strict sequential attack chain, the correlation and timelines provide strong support for our hypothesis that the system was experiencing coordinated database-related campaign activity.